Welcome back, everyone. So, as I mentioned in the last lecture, in this lecture, I'm going to look at more the effects of hedging. So, to start off, I'm going to try to make a function in order to functionalize, essentially to take the benchmark return on the stack looking at, and then returning back an alpha and beta value. So, essentially, we're going to create a function called alpha beta, and it takes in some, let's say, benchmark underscore return, and it takes in some stock. And what it's going to do is going to run the vanilla regression that we did previously. So we could say benchmark is equal to sum as constant and pass in benchmark return. And we're going to create a model. And we're going to call it a regression model, a linear model, OLS, and it's going to be run on the stock with that benchmark. So note here that this benchmark is one of the constant that I'm putting over here, transformed from the import benchmark recurse, and we're going to say dot fit, and then what I'm going to do is return the model dot parameters, and I'm going to return it as a tuple and say model dot one. So now essentially we've made a function from what we did on the linear regression. What we're going to do here is start off by getting the alpha and beta estimates from the last year. So I'm going to come up here and copy paste some code that we previously did. Essentially what I want is these few lines of code here, as well as the benchmark. I'm going to copy those over and bring it down all the way back down here. And I'm going to copy paste it here. And we're going to call this cell essentially my 2016 cell. So here's my data for 2016. I have an asset, I have one benchmark, and let's label these asset 2016, benchmark 26, because later on we're going to be end up using this for 2017 as well. So then I'm going to set my asset return 2016 to be equal to the asset of 2016, percent change 1, and then I'm going to grab everything from the 1 and beyond. And we're going to essentially copy and paste this. Actually, I'll just rewrite it. Say benchmark return 2016 is equal to benchmark 2016 percentage change, and also going to grab 1 onwards. And then what we're going to do here is just a couple more steps. We're going to get the asset return values, so we can end up plotting some of this stuff and being able to pass it to the alpha beta function. So you're going to say asset to asset return values, and then we're going to say benchmark returns is equal to benchmark returns 2016 values. So I can use this information for plotting and this information to pass into the alpha beta function. So you're going to say alpha 2016 beta 2016 is equal to the function call alpha beta, passing in my benchmark return values and then the asset return values. And then let's have a couple of print statements out there. So we could say something like 2016 values, and then going to print the alpha, and then I'll just concatenate that with the string alpha 2016. Then I'm going to print beta, and then concatenate that with the string of beta 2016. So, okay, so we'll let that run, and this should give us some of the information for 2016, and it should give us an alpha value for 2016 and our beta value. And this is for Apple stock. So what we're going to do now is essentially create a hedged portfolio and compute alpha and beta from there. So how are we going to do that? We're going to create a portfolio object, and we're going to do exactly what we did previously. I multiply by -1 to inverse the beta. By 2016, I'm going to multiply that by my benchmark returns for 2016. And then I'm going to add my asset returns of 2016. So we're going to run our portfolio and do the following portfolio and say alpha beta equal to alpha beta, and then we're going to pass in the same thing we did last time. I'm going to say benchmark return 2016, and I'm going to pass in my portfolio. So then I'm going to say print portfolio alpha and beta. I'm going to print a couple more things here, alpha, and can connect that with a string alpha, and then we're going to say beta and plus a string of beta. And so what is actually going on here? Well, they first calculated, based on 2016, the alpha and beta values for Apple versus the market. And those were alpha of 1.6 times to the 10 to the negative 12 against a beta of 1.02. So you can see that there is some behavior, and alpha does move with the market. So that makes sense. So then here we said, I just want to trade on alpha itself. So we're going to say portfolio minus 1 times the beta value for that 2016 times the benchmark for 2016 plus the alpha term, which is the asset. So we run this to the alpha beta to aggregate back to the alpha beta on the benchmark of returns to the 16, the portfolio, the hedge version. And now we can see that we have some alpha value that is essentially the same, but our beta is almost 0. As you say, it's 1.3 times 10 to the mix. So essentially, we've completely eliminated the beta. So what we have here, we are trading now completely on alpha, which is Apple itself. So now we could plot this out just to show, just to make it more clearer to you. And we're going to say portfolio dot plot, and let's give this, let's make it more visible, more transparency, and then we're going to give this a label of Apple with the hedge. And then I'm going to say my asset returns for 2016, and plot those out, and let's give this an alpha visibility value of 0.5, and then my benchmark returns of 2016, and plot those out with an alpha value of 0.7, just to make it more transparent and visible. And say PLTY level on the daily return, and let's give this a legend as plt.legend. So we run this and we end up getting a chart that looks like this. So again, we can see here, which is essentially what we did last time, essentially, but this time we functionalized it. So we could see the Apple hedge. There's a big dip in the market around July, but the Apple hedge doesn't respond to that behavior. You can see that the blue value disconnects itself from the market. But that does mean for the big drops and the big peaks, it does follow. So, okay, so what does it actually mean in terms of the average returns? So if we take a look at our portfolio, mean value of this, these are our average daily returns, 1.67 times the 10 to the minus negative 5. But if you check out the asset itself, in asset returns, so you get the mean value here, you get getting 0.005. So the general idea here being that we've greatly reduced the effects of the market. We've kind of reduced the average of the effect of the market. But if we have a look at the volatility by looking at portfolio point standard deviation, and if we look at just the asset itself, standard deviation, we could see here that we've reduced our volatility standard deviation by not a whole lot, by 0.14. So is that worth the huge returns in our mean value? It's all relative, and it depends on it depends on the market. So the take from here is that Apple is such a huge player in the market that the effects is quite positive in terms of the movement within the market. So I'll just leave it over there. And uh, if we want to do it for 2017, it's essentially just the same thing. And we could just change it around and copy paste everything down here. And we're gonna copy paste that for 2017. And let's see what happens. So if you notice, if we look at alpha 2016 and alpha 20 beta 2016, sorry, that there is definitely some change for this starch. So now we're going to create a portfolio based on the 2016 estimate. Say something like portfolio -1 times, and previously we used the perfect beta value, that is beta 2016 against the benchmark returns of 2016. But we're going to pretend that we didn't have access to 2017 information. We had to use a historic beta value. So yeah, we're going to multiply it by beta 26, and we're going to attempt to hedge by historical uh, data information, and then we're going to add the assets. So now we've created a portfolio that uses the previous year's beta on today's information, and we're going to say alpha beta is equal to alpha beta, and then we're going to pass in the benchmark returns for 2017 and my portfolio itself, which is the new portfolio value over there. And now we're going to end up doing is pass in what alpha is and what beta is now. And we're going to compare this to see how well they actually work against the previous figures that we calculated and the previous alpha and beta values. So our beta is not 0. That's because we're using beta 2016. So let's go ahead and plot out what this comes out as. So let's say something like portfolio, like previously, and look at the mean is 0.0011 versus my actual assets reserve for 2017, and we look at that mean, and that ends up being slightly greater. So you can see we reduced our average return, but hopefully we were able to also reduce the volatility on the standard deviation. So let's look at asset returns and standard deviation, and that's 0.01. So kind of dropping it by 10% again. So the most common trade-off here is that we typically sacrifice average returns for less volatility. So again, this is highly dependent on the security, and as we can see, like Apple is a big chunk of the market, so they will have much stronger beta values because they themselves are define the way the market moves and have a big effect on the beta of the market.